So, welcome everybody to today's puzzle, which is about magic squares. Yes, again, magic squares, because there's another magical property of magic squares that we didn't see yet. We've seen lots of properties of magic squares, but not this one, which is quite unexpected and surprising. So, let's get started. And to begin with, we need a magic square. So, let's assume that this is a magic square. And the property that we want to prove, that I want you to prove, is that in any magic square, the sum of the squares of the numbers in the first row is equal to the sum of the squares of the numbers in the third row. So to be more clear, what I want you to prove is that a squared plus b squared plus c squared is equal to f squared plus g squared plus h squared. So, pause the video, try to prove it, and when you come back, I'll give you the explanation if you didn't find it. So, go try. And for the solution, let's start by checking this property with the most famous magic square, this one, the one that only uses the numbers from 1 to 9. And so in this case, we have the numbers 8, 3, and 4 in the first row, so we have to calculate 8 squared plus 3 squared plus 4 squared, and that must be equal to the sum of the squares of the numbers in the third row, that is 6 squared plus 7 squared plus 2 squared. So we calculate that and we get 64 plus 9 plus 16, and that must be 36 plus 49 plus 4. We calculate that and you get 89 equal to 89, so in this case it works. And so we want to prove this in the general case for any 3x3 magic square. So you need to remember that in any 3x3 magic square, the sum of any row, column, or diagonal is always 3 times the value in the center, 3x in our case. And if you don't know this, just watch the video down here, I'll leave you the link. So we can use this property and write down that a plus x plus h is equal to 3x, because that's a diagonal. And also b plus x plus g is 3x, because that's a column. And we also have that c plus x plus f is 3x, because that's the other diagonal. And from here, we can get the values of a, b, c in terms of h, g, f, like that. And we're gonna use them. So let's now write a squared plus b squared plus c squared and substitute the values of a, b, and c. So we now have to calculate the squares of these polynomials, and in the first case we get 4x squared minus 4xh plus h squared. And in the second case we get 4x squared minus 4xg plus g squared, and in the third case 4x squared minus 4xf plus f squared. So we add everything up in columns like that. So in the first column we get 12x squared. In the second column, we collect the minus 4x, so we get minus 4x times h plus g plus f, and then we get h squared plus g squared plus f squared. And now you need to remember that h plus g plus f is just the third row of the magic square, so they add up to 3x like any other row. So we write 3x, and 4x times 3x, that's 12x squared, so those two terms cancel out like that, and we get the solution. Hope you liked it, hope you learned something, and I'll catch you on the next one. Bye!